Hello everyone, and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
Not sure. What am I doing?
So today we are going to take a look at a very interesting board. It might not be the most powerful board out there. It's not gonna break any benchmark records. It's not gonna have high scores in anything maybe, but that's not the point of this board at all. This board is just $10 and it runs Linux. Yes, believe it or not, this SBC costs less than a Starbucks caramel ribbon crunch frappuccino basically. So it can run Linux and do so many things, which we will explore in this video. As you might have seen in the video title, the board I'm referring to is called MilkVDuoS. And drum roll please. Ta-da! Here it is. So I got the two variants of it. There are many variants, to be honest. So I got these two bad boys. Let me show you the back as well. Yeah, okay. For now, I'm gonna open it. So there are like two versions of it. One with eMMC, one without eMMC. So just for fun, I got both. So one of these bad boys does not have eMMC. One does have 8GB eMMC, but I don't know which is which because there is no marking. Let me grab a knife. Okay, got this a little bit the plastic wrap. Okay, that's one, and that's two. Let me get rid of the knife. All right, so let's take one of them out at least. Okay, let's open it up together. I don't know what is inside. Okay, come on. There you go. And it came with an antenna. Look at it. It's beautiful, isn't it? Look at it. Just look at it. Beautiful little board. And the back, okay? It's beautiful. Now we're gonna talk all about it. Just for now, take a look at it. Okay, so the antenna goes here, I assume, which I'm kind of sure. Let's do that first. Okay, so the antenna goes on there. I bought the one with Wi-Fi 6 and Bluetooth 5. Anyway, we're gonna talk about it. So basically, the one with 8GB eMMC was like $18. The one without the eMMC, that was like $12. But the board is literally listed on many other sites for like $9.99. I bought mine from a website called Araki. I don't know, maybe they're Italian, so maybe Arace. I don't know. So whatever that website is called or how it is pronounced, I bought it from them. A-Race, maybe? A-Race? I don't know. E-R-A-C-E. Yeah, so I bought it from them. And let's talk about the board. Forget about the vendor. So this board is actually... It comes with Sophgo SG2000 SoC. So let me tell you a little bit about this SoC first. So the SoC comes with one C906 64-bit RISC-V core, which runs at 1 GHz speed, okay? And then there is another core, which is again C906 64-bit, again, RISC-V core, but that one runs at 500 MHz. And then finally, one ARM Cortex-A53 core that runs at 1 GHz. So you can basically switch between ARM core or RISC-V core, and the switch should be, yep, there you go. Yeah, you see that? That's the switch. So this toggle here, you can go between ARM and RV, RISC-V, right? So you can switch between the two. Okay, got that? Good. All right, we'll talk about it, and like we're gonna load some Linux and do stuff with it. We're gonna talk all about it. Also, this SoC comes with an MCU, and it's a 8051 8-bit microcontroller core, which basically runs from like 25 up to 300 megahertz and comes with an 8 kilobyte SRAM. This one does not come with a GPU core, kinda obvious, right? But it comes with something called VPU. You might say, you know, what is a VPU now? So that's a good question. VPU is a specialized type of, you know, microprocessor that is designed to kind of like rapidly process, interpret large amounts of data that are generated by digital cameras, right? You connect the CSI to this board. There is one. We're going to talk about it. And that VPU, which stands for Vision Processing Unit, got that? that? Okay, so that VPU will be able to basically do video encoding and decoding, and it can do H.265, H.264 at 5 megapixel at 30 frames per second. Okay, so don't expect a lot of horsepower, but it is still impressive. Imagine you're getting a RISC-V core, you're getting the ARM core, and you're getting a VPU, but wait, there is more. So the SoC also comes with an NPU. So NPU is, we talked about other boards as well. They also RK3588, RK3588S, SBCs that we talk in this channel. They all come also with NPU. And this one, this bad boy, can do 0.5. It's half TOPS. And TOPS stands for trillion operations per second. And yeah, this contains that as well, that chip as well, that core in the SoC. And also the SoC comes with 512 megabyte DRAM, and also, by the way, I've seen some other sites refer to the NPU on this as TPU for like tensor processing unit, kind of like what you see in TensorFlow, right? So tensor processing unit as well, it's the same thing, don't get confused. So that's about the SoC, I would say. So we covered the SoC. Can you see it on the camera? So you see that this black blob? Yeah, that's the SoC. Okay, got that? All right. So this SoC, we covered the SoC, right? And let's talk about the board itself, right? As I said, there are like options. The board with Wi-Fi and Bluetooth, which is this one, there is one with eMMC, one without eMMC. You can choose, but it is like $9.99. It's like $10, the Starbucks drink. In terms of I/O, so there's one right here, USB-C port, which is used for powering the board and data, okay? And then there is one USB 2 host here, okay? And this one, I saw it somewhere on their website, the RISC-V website, MilkVDuoS website, or somewhere there anyway, and you can't use it simultaneously. You have to switch which you want to use from the terminal, okay? And I saw some commands that basically you can just copy paste. We're gonna try all those things that I see in their documentation. Anyway, there's also an Ethernet port, but again, it's not gigabit or anything, so this is 100 megabit per second. Good enough, you know, in this processor and this board, you're not gonna be able to handle more than that anyway. So yeah, it's a 100 megabit per second Ethernet port, which, as I said, there's also Wi-Fi 6 and Bluetooth 5. And as for audio, they are saying you have to do it with GPIO pins. And as for CSI, you know, there is a CSI connector here, and there's also, they're saying the CSI connector, it's 16p FPC connector, and MIPI CSI, basically 2-link. And for DSI, they are saying you have to use the GPIO ones, okay? And as for the GPIO itself, as you can see, there's in like both sides, right here and there, okay? In both sides, there is like 26 pin on two 26 pins, right? 13 row and 2 columns and 2 sides, 26, but they were saying 29 GPIO pins. So some others are not really GPIO. So I don't know. That's what I saw in the documentation. I'm opening it with you. I don't know. I haven't executed anything on it. And the power supply is, by the way, 5 volt, 1 amp. Just keep that in mind. Obviously, low power requirements. And also you can run a Linux on it, as I said earlier, and also an RTOS. RTOS is the real-time operating system, right? So you usually see RTOS in low-end wireless routers and stuff. That's more common. Obviously, RTOS isn't everywhere in a lot of industrial stuff, but for, you know, normal people, usually what you encounter is like in those things, in like wireless routers and such. But there's like free RTOS, there's VxWorks and others. You can build your own RTOS and application. So you basically kind of like compile an OS, compile, let's say, free RTOS and VxWorks or whatever, and build your app with it and flash it into this, and it will run it. So it will basically save you a lot of, you know, processing power. Like, let's say if you run a full-blown Linux, it's gonna have a lot of background processes, foreground processes, functionalities you don't need. You use basically what you need. need, right? You cut it down, cut the fat very, very thin, and you get what you need, right? So there's no extras. It's just the pure Linux core that you need. Full RTOS, it's all what you need. So yeah, overall, from the looks of it, just by looking at it, you know, just holding it in my hand, I just love it. I really, really hope now I will be able to get everything to work. You know, just, I don't like Monopoly, right? Who does? So don't get me wrong, I like, you know, 64-bit x86 CPUs, I like AMD, Intel, whatever, ARM CPUs, all the phones now run on ARM, everything. But, you know, I just like RISC also to take off. Yeah, I just wanted to take off badly. RISC, by the way, there are so many YouTube videos out there. I don't like to really repeat things. And also, the main point is the others can explain it better. So that being said, if you're interested about RISC architecture, what it is, why it matters, how it all started, the history of RISC and ARM, and all that stuff, there are so many YouTube videos out there, blog posts about it, write-ups, everything. Go check those out. But like on very high level, I'm gonna butcher it, but anyway, RISC stands for like reduced instruction set computer. So to oversimplify it and butcher it, so RISC CPUs, let's say, have very few opcodes, right? Opcodes, instructions. So yeah, the RISC architecture, let's say RISC-V, this one does have 28 opcodes, 28 instructions, right? But like a regular modern x86 64 CPU, like your Intel that you buy from the store at the AMD these days, whatever you're buying, those come with like 3,684 something instruction and opcodes and variants and stuff, and like 981 unique mnemonics and all that stuff, right? It does a lot more, obviously, but that's also very expensive, power hungry, heat, all that stuff. This, none of that, right? 28 opcode, just keep that in mind. And it can run freaking Linux, right? So fingers crossed though, I don't know. I haven't executed anything on it yet, but yeah, I hope I won't regret anything I said. I love it, and I'm gonna try what I can do with it. And obviously, as you can see, there is no HDMI or anything, right? So we are going to run a Linux, and then I'm gonna try to connect to it. I don't know, I didn't check the documentation. Maybe there's a UART, maybe there is a SSH. Anyway, I will figure it out. Give me a couple seconds. Enough mumbo jumbo, you know. Let's get some action going. Let me power this bad boy and see if I can connect to it some way, and I will be right back. By the way, I'm sorry, before I go, so I was wondering like which one is which one. It's so easy to spot, right? There you go. So this one does have that 8 gigabit eMMC, this one does not. So no rocket science, you don't need to, you know, read the label or anything. There is no label or anything on the board itself, so on the box. So once you get it, if you buy bunch and you don't know, so you just flip the board over and look at it, and there you go. This one got the eMMC, this one is not populated. I wonder if I can put something on it, right, myself? Anyway, doesn't matter. So let me get an SD image, SD card here, by the way. This is the SD card slot. So let me get an SD card image and see if I can turn it and, you know, start. All right, I will be right back. Okay, so I got some good news and some bad news. Okay, so they are kind of both related. So as you can see, here's what I did, right? So I got the UART connection going on in here. Okay, so these are the UART ports. That's all in the documentation. Okay, nothing special. And this is a cable that I'm using, right? So this is the C232HM, and I've shown this in the other video where I'm talking all about UARTs and SPI chips and all that. If you haven't seen it, go check that out. So here, that's all, right? There is no screen, as you know, there is no HDMI or anything on this, so we are going to use the UART to see what's happening. Now let me show you what I found in the documentation and all that, right? So I plugged that in. So first, very quickly, as you can see, this is my cable, right? Doesn't matter, you can use whatever you want, any other alternative cables. Just make sure it's 3.3 volts, okay? Not the 5 volt UART. Don't use that, you might fry something, okay? And then once you look at the pinouts of that, you will be able to see that which one is the TX, which one is the RX, right? So you can see that in here, orange and yellow and orange and yellow, okay? So that's, now we know that. Now let's go about the good news first. So the good news is, honestly, I just followed the guide, right? I didn't do anything. I just followed the guide that's in here, right? Build root SDK. I literally copy pasted these commands and didn't do any changes, any modification, and I was able to build the Linux for it. So I will show you right now on the screen the build process. So as you saw in that sped up footage, I was able to just build this image and it gives me an SD image, and I was able to just write that to SD card. Okay, so this is the almost 900 meg SD card image, which is Linux, and I made some modification. I put my Technic launcher here and there. So yeah, I just literally copy pasted the commands, and once you run the build.sh, it tells you, which one you want to build, which I went with MilkVDuoS SD. So once you run build.sh with that argument, it builds that whatever you're going to see now. So I have plugged in the UART cable, okay, and on the other console here, I am going to run this, like screen, okay. So we are going to connect to that TTY port, okay, and now I'm going to power it on, and you can also from the other camera, you can see the power consumption. Anyway, it never exceeds 1 amp, okay, so 5 volt 1 amp, that's what you're going to see. Okay, that's what you're going to see, and it's going to boot. Okay, it's gonna all the way, yeah, there you go. It dropped to a shell. Okay, now if I do like cat etc issue, you're gonna see that, yeah, welcome to build root, hello from technology. I told you I put it in here and there in the banners just so you can see this. I built that image. I just literally cut pasted commands, nothing special at all. So if we look at the etc OS release, you are going to see it is the build root, and it's a custom Linux. Okay, and if we look at the uname, you will see that is 510. Okay, we see that a lot in the RK3588 images, usually the ones that are provided by the company and the manufacturer of those boards. Anyway, 510. Okay, and as you can see, it's RISC, right? So we are getting this to work. Okay, but unfortunately, that's where the good news kind of ends. Okay, so the thing is, they are saying on their GitHub page and as well as in the documentation, they don't have anything for this board. Okay, just remember that. So let me show you. Once you go back in here, right, and they tell you to download a pre-made image from GitHub, right? If you want to go there and go to the release, you will see that it says known issues. DuoS does not support Arduino. Duo 265 and DuoS does not yet support wiring X and ping pong. So I wanted to turn on an LED and check the volt with the voltmeter and all that stuff that I usually do with the GPIO. I could never do that. It did not work. I tried with various pins, pin chips, I kind of, not too much, I just brute forced it here. So if we do sys class GPIO, you'll see there are a bunch of chips in there, and each chip have a bunch of pins in there. I didn't dig too deep, but from what I saw and what I tried a bit here and there, tried various numbers on the pins, I couldn't get it to work. There is also a documentation stuff in here. So they have in the datasheet for DuoS, this is alpha as you can see. So this is committed 2 months ago and they haven't updated for 2 months. And I was able to read through this. I tried all these pin numbers, I tried all these functionalities. I couldn't get it to work. There is no documentation what GPIO number in sys class GPIO, the correlation between the pins on here and the pins in the GPIO. I couldn't get to work. Wiring X does not work. Yeah, basically you can't right now, today, as of recording this video, you cannot turn on an LED using this board yet. But I'm sure a company who built this, right, the MIP5. So, and also the way they built this build root thing that I was able to literally just copy paste commands and build it. I'm sure a company that can do that will be able to fix the wiring X and support and documentation and all that stuff. So yeah, kind of for now we are stuck there. Okay, just so you know that we'll keep going. Okay, there is other documentation. The thing is, it's all Chinese, right? The whole documentation, even that alpha one, I know there are some English parts, but most of it is all Chinese. So there is a dual example, by the way, and also by the way, I saw that in their community there is some other people also complaining about the GPIO and asking where is the GPIO map. So I didn't see anyone responding to them in their community forum, whatever. So just so you know, you can't do it right now. But the thing is, it's very well documented in terms of build routes, like building your own Linux kind of. And yeah, so the other thing I wanted to do it is the RTOS. So as you can see, there is an RTOS in here where there are like 2 cores, right? We went through it, we talked about it. There is the ARM core and the RISC core, right? And they have given you an example where using the RTOS OS, you can communicate between the RISC and the ARM cores, and it explains it here. So this example is a Linux application runs on the big core, which use the mailbox driver in the Linux kernel to notify the small core, that free RTOS, to control the blue LED. Okay, so we're gonna try that now. Okay, as you can see, when you boot into this image, this blue LED is blinking. You see that? that? Yep, okay, yeah. So that is blinking, okay? So, as that is blinking, now let me show you where that is coming from. So if we go to MNT, and if we go to system, I think. Yep, there you go. So, cat blink.sh. So the only GPIO number that they have documented is the GPIO for that blue LED. And that one is 509. So 509 correlates to that blue LED. So that one, yes, we can manually turn it on and off. So this blink.sh is started with the system boot, okay? So if you don't want it to blink like that, they are saying in the documentation that you need to rename that and then reboot the system. So we are going to do that real quick. So we are going to rename the mv blink.sh to blink.sh.alt, okay? And then a reboot, okay? And it's very fast, you'll see now. There you go. So it literally takes a couple seconds and it boots, okay? So the reboot is fast. And as you can see, hopefully in the camera, let me show you again. No blinking, okay? It's solid, all right? So keep that in mind. Now, let's do something. Now let's do one thing. Let's go back to MMT system, right? Blink.sh. Remember, it's pin 509, okay? And if we echo to, maybe it was already exported. Let's try, because it didn't get executed this time, right? So it was not exported. Now, let's do echo out to sys class GPIO 509 direction. There you go. I hope you didn't see that. So it is not blinking and it's not on anymore. All right, it's not on anymore. There you go. It's off. And if I do echo 1 to sys class GPIO 509 value, okay, look, there you go. You see, it turned on. And if I go up and turn that to 0, look, there you go. All right, so we got that. Now what they're saying in their example is basically you need to clone the duo example page and then compile this free RTOS example in the duo examples directory, okay? So, and I already have done this, all right? So what you can do is, I already have this, let me show you actually. So duo examples, okay? And where is it? Yeah, cd mailbox test, okay? Let me open that up, okay? So what you need to do is you can say source and setup. First, you need to set up your build environment. You follow the guide, it's very well documented, honestly. I didn't do anything special, okay? And then basically we just run a make, and if we do ls, you will see that we compiled it, okay? And now what we can do is copy that to that board, okay? And we are going to test the Ethernet, okay? There we go. We got the IP address. All right. So it got the IP address. Now we are going to SCP this file. SCP mailbox test to root at this IP to /root. Okay. Yes. And the password is MilkV, Milk5. All right. So if we go here to root, there we go. So we got the mailbox test. Now what they're saying is just move it in there, chmod, disable that, and execute it. Now look at the LED. If the LED now turns on, it's happening from the RTOS store. Okay. I'm going to run the mailbox test. Okay, what did it say? Oh, yeah, so this is one of the things that I had to fix manually. So that's not in the documentation, unfortunately. I'm sure they are working on it. Lib wiring X. So let me show you how I fixed it. If we go to this one right here, okay, as you can see somewhere in here, I saw it. Yeah, here you go. So the library folder, I saw it that it's coming from here and here. Okay, so what we can do is we can ls this. And if the wiring is here, nope, it's not there. And if we ls this one, yep, it's right there. Okay, so what we are going to do is watch scp this lib wiring x.so to root at 124 /. It goes straight there. MilkV, okay, and I believe there is no LD config in this. Yeah, so I think this should work right now as is. Let's try it again. Open failed. So I guess it's not exactly bulletproof, the guide, the documentation. So yeah, we compiled it, we moved it, but it's not exactly working. Or maybe I missed a step. Hold on a second. No, I don't think I did. Yep, I don't think I missed a step. So I guess it's still, they're working on it or something. It's not working. I was able to turn on the LED with GPIO, but not with the mailbox example. That one didn't go through. And that one is failing. So keep that in mind. Yeah, so, but at least I wanted to show you that the examples are building. The SD card image building is working. I also tried the stock one that they share in the release folder in GitHub. That also works. Arduino is not supported in Dual yet, so they are working on it. And also the 8051 core, again, there's no examples for actually actually DuoS. I'll show you. If you go here, you go through the steps and all that stuff. But when you want to actually use it with the pins and all that stuff, there's nothing specially for the DuoS. So this is not complete. So what you can do right now with this is just building a Linux, running it on this machine and this board. And as you can see, it's 5 volt 1 amp, right? It doesn't use a lot of power. It boots, it gets the Ethernet and IP address. SSH works. You will be able to SSH into it, right? I did SCP, but yeah, you can SSH as well. Yep, so there is no APT or anything like that, but you will be able to compile the codes using the Duo build example environment and compile it with the cross-compiling tools and then push the application to the board and run it. And that's kind of pretty much it where it is at the moment. They are working on it. I am 100% sure they're working on it. The GPIO, lib wiring, and all other stuff, it will come out, and hopefully I will be able to do a follow-up video. But right now, as is, the examples, the code, and the libraries, and the support, and the GPIO, and all that stuff, it's not there yet for this particular board. Okay, so keep that in mind. You can definitely buy one. It's $9, $9.99, right? $10, and with the Wi-Fi and all that stuff, a little bit more. Yeah, overall it works, but that's the limit where it is right now. It is going to get better. Hopefully more documentation will come, but right now that's kind of it. You need a UART cable? Yeah, maybe not. If you connect an Ethernet and monitor your DHCP server and then notice the IP address that your DHCP server grants to the board, then you can just straight SSH into it. You don't need a UART cable if you want to do it that way. But I think UART is a better option here because you will be able to see other logs and other things that are getting printed on the screen, and maybe you want to do some other custom development in U-boot or something else, and you will be able to modify that. Anyway, that's a very quick video I just wanted to make. I hope I didn't make it long. I keep saying I want to make short videos, but it keeps getting long. Anyway, thanks for watching. I will keep an eye on this and development, and if they release more information and examples, I will make an updated video. But it is exciting. And by the way, it's not hot at all. You know, I didn't put any heatsink, as you can see. So pretty cool board. Very, very, very cheap, and it's a RISC computer. So exciting stuff. Hopefully they will deliver with the remaining of documentation and libraries that is needed to use this board. Thanks for watching, and I will see you in the next video. Bye for now.